In this video, we're going to talk about the ARM platform and Android. So, what is ARM? ARM is actually a specification. There's a company that used to have a name with an acronym of ARM. They actually changed their name to ARM, and they make specifications, but they don't make chips. The chips are actually made by other companies, such as Atmel, Texas Instruments, etc. Now, ARM chips are widely used in the low power mobile devices, things like smartphones, embedded devices. So they're used because they are very low powered, which is great if you're having to power something with a battery. They also have a RISC architecture, or a reduced instruction set architecture. That is different from your typical Intel or AMD desktop chip in that those are what we call complex instruction sets. More about that in a bit. The ARM architecture is the most common that you're going to find for Android devices. It's not the only supported architecture, but is by far the most common. And within the family of ARM devices, the most common that you're going to find is the ARM7 architecture. Now, the ARM7 is intended to be a general purpose chip. There are older ARM specifications that are intended more toward microcontroller type applications. So essentially something you might do with an Arduino or something similar. Now, the Raspberry Pi, the original version, is an exception to this. It uses the older ARM6, and that is one of the hugest issues with that device. It has very poor support and very poor performance because the ARM6 was never intended as a desktop chip. They did come out with the Raspberry Pi 2, which is finally on board with everyone else and using ARM7. So how is it different? It's RISC. So there are less instructions. However, the instructions are faster. If you look at a CISC chip, such as those found in your Intel box, you have instructions that might do really complicated stuff, but they might take 8 clock cycles to run. On a RISC architecture, there aren't as many instructions. However, most of them are going to run in a single clock cycle. So every time the clock ticks, if it's a 1 gigahertz clock, something gets run. Another difference, there are no operations that operate directly with memory in the ARM platform. There are also a lot more registers as a result of this. So you have 16 registers. You have 2 kinds of commands. You have 32-bit or 4-byte wide commands, and then you have 16-bit or 2-byte wide commands as well. So the 32-bit wide commands are called ARM, and the 16-bit are called thumb commands. So why would you want this? Well, if space is at a premium and you want something to be small, having the 16-bit commands obviously is going to conserve on space. Also, there are commands that work on multiple registers. Again, because there is not this direct memory access, you have commands that'll work with multiple registers at a time. Now, when it comes to calling conventions, the first 4 parameters are passed in registers, and a special register may be used for the return address. So what does that mean for us? You're going to have a problem if you think that you can do a simple stack buffer overflow in order to take charge of an ARM-based, especially Android application. So you're going to have to go about things a slightly different way. What should we know about Android apps? Android apps are mostly written in Java. They use a specialized virtual machine known as the Dalvik virtual machine. If you know anything about Java, you know that Java takes away things like memory management from the user. However, the virtual machine is written in C, and it is subject to the regular C program vulnerabilities. So there's always a chance that you could find some flaws in the Dalvik virtual machine itself.